Hi everybody, today we're going to be working on our review assignment to help us prepare for our Air Masses quiz. It's going to be really important you guys spend some time on this assignment. With being on winter break for a while, it's going to be really important to go back and review the concepts we were learning about before winter break, okay? So this assignment you can find in this Q2 Week 7 folder, and it's assignment number 2, Air Masses Lesson 3 review. Very similar to the last review assignment we had. You're really going to want to have either your write-in textbook with you, or you're going to want to use your eText Air Masses reading lesson that we worked on before break. And you want to start by downloading the document and then open it in Notability. Okay. So this is what you'd want to have open in your eText, Lesson 3 Air Masses. And this is our assignment over here on the right side. I'm going to kind of go through the questions here, talk about them a little bit, help review it with you, and show you kind of where you can review this information in the text. All right, so our first question was, what is the difference between an air mass and a front? Remember, this whole unit was all about air masses. You can find this on the second page of our eText assignment. If you scroll down right here, underneath these couple reading check questions, we actually highlighted it right here. So air mass is a huge body of air that has similar temperature, humidity, and air pressure at any given height. Remember, so we learned about different air masses that affect the weather in North America. Like one example might be continental polar. Remember, it's a air mass that forms over the continents, over the polar regions. We talked about maritime tropical air masses. Those are air masses. When it says maritime, remember they form over the oceans and they're very warm and have lots of moisture in them because they form over water. So the question's asking you, what is the difference between an air mass and a front? Okay, so air mass is just a big body of air, right? When we have two air masses that come together that form a boundary, that's what we call a front. So if we go to remember these are the air masses here that we can see, but when we have a boundary between two air masses that are next to each other, we call it a front. So it's really important for our quiz that you review the different types of fronts. So I think this is on the third or fourth page. And if you go down to the bottom here, actually on the next page, you'll find some nice diagrams to help you review the different types of fronts. So we go through it in the reading right here. We highlighted all of these. We did this in one of our connections meetings. So you're reading about cold fronts, warm fronts, occluded fronts, stationary fronts. So if you want to review different types of fronts, which we'll be using for number 3, you have all the different fronts right here, and you can look at the picture, you can read about them, and you can see how they're different. But remember, a front is a boundary between two different air masses. So when you're answering question 1, the main difference is that air mass is just a body of air that has similar properties, but a front is a boundary between two different air masses. Okay. Question 2, a state often has cold, snowy winters and cool, rainy summers. Is a state more likely to be New York or Nebraska? Explain your answer. Well, what I would do for this one is I'd go back and look at the air mass map in your eText. This one right here. And so if we think about, we have two locations. We have New York. New York is up over in this area. Okay, I'm pointing to it. And you can see you're really close to the ocean, right? And Nebraska, right, that is just a little bit southwest of Minnesota, kind of over in this area where I'm pointing to, right? Kind of smack dab in the middle of the continent, far away from oceans, right? These are going to be mostly continental air masses that impact you. And in New York, you're going to have a lot of maritime air masses, as well as continental polar air masses that can impact you. So I want you to think about what you know about the weather around us, close to Minnesota, Nebraska, and compare that to the weather in New York. And which of these states do you think is often going to have cold, snowy winters and cool, rainy summers? So if you think about where we live in Minnesota, we're not that far from Nebraska. We definitely have cold, snowy winters, right? But we don't typically have cool, rainy summers. Typically Minnesota summers are very hot and humid, right? I wouldn't say they're really cold very often. So I should give you a big hint about which state would have that type of weather. And again, it's going to come down to what types of air masses are going to impact that state the most. Okay, and also where is it located as relation to the equator. Okay. All right, for number 3, this is a table and it's showing you some different types of fronts. And you want to match up each type of front with that. So what I would do is I would go back to the fronts where we have our model of those in the e-text. And these are our models here. And what I would do is I would compare these to the descriptions here. So the first one says a cold air mass pushes under a warm air mass. So it's talking about the cold air masses moving into the warm air mass. So if we look at the arrows, you can see the directions they're moving, right? In this one, we have a cold air mass that collides or moves into the warm air mass, right? So I would call this first one, I would say this would be a cold front. Next one, a warm air mass is trapped by 2 cold air masses. So remember, there's another type of front where you get a couple different more than 2 air masses interacting. You have kind of 2 cold air masses on the side and a warm air mass trapped in the middle. So if I look at this one, I only have 2 air masses here. It can't be that one. The warm air mass is not trapped between 2 cold ones here, so it's not a warm front. Let's look at a occluded front. Well, I've got a cold air mass here, another cold air mass here, and a warm air mass in the middle. Okay, so that's a possibility. What about a stationary front? We'll have a warm air mass and a cold air mass, but really nothing in the middle. So the only one where I have something trapped is this occluded front. So this would be a occluded front, right? For this one, I'd write occluded front. The next one says a warm air mass rises over a cold air mass. So if we look at our pictures here again, if we look at this one, it shows the warm air mass is pushing over the top of the cold air mass. So this third one would have to be a warm front. And the last one, the front does not move. Well, if we look at this one, that's the only one we have left. Remember, they just kind of get stuck next to each other. They don't push into each other. And that one's called a stationary front. And also keep in mind, look at what types of weather we have associated with these different fronts. Remember, a cold front, you get thunderstorms and strong storms. A warm front, you get kind of lower clouds, cloudy days, and rain. A occluded front, you might get severe weather, tornadoes, strong storms, again, because that warm air is forced up. In a stationary front, you can get kind of a mix of weather. All right, then we're on number 4. So it says use the 2 models to show the air pattern in a cyclone and an anticyclone, and sketch the arrows to show the direction that the air travels. Well, in our last assignment this week, we looked at low pressure systems and high pressure systems. Remember, we had to draw how the wind was moving around those. So it's actually really similar to what we're doing. But if you go to the next page here, you can read about cyclones and anticyclones, remember? So in a cyclone, we have air rising, right? And that air cools and forms clouds, and we get precipitation. And the winds, say, spin counterclockwise. Well, the one that shows air rising would be this one, right? Because I have clouds forming. So this would be a cyclone. And we'd have to draw a circle or some arrows to show that it's going counterclockwise. So counterclockwise would be this way, right? So I would draw an arrow to kind of show that it would be going this way. Now this one would be an anticyclone because you have clear skies. In an anticyclone, you have sinking air, and so no clouds are forming or condensing. And in an anticyclone, the is spinning in the clockwise direction. So it would be this way, the opposite of the one next to me, right? So this one would be the anticyclone, high pressure. This one would be the cyclone, low pressure. Remember, low pressure, we have rising air and clouds. High pressure, we have sinking air and clear skies, nice weather. So you're going to have to know that for our quiz coming up this week. All right, the last question, I want you to do the quest check-in here. It says, in the lesson, you learned that air masses interact at fronts. You also discovered that interacting air masses can cause severe weather. Why is it important for people to understand how interacting air masses can affect the weather? So I want you to think about why is it important we understand what air masses are and what happens at the boundaries between air masses, right? Because remember, when we have two or more different air masses next to each other, that is where we have something called a front. And a front is where we often get a lot of our different weather occurring, like rain and thunderstorms and snowstorms. So it's important to understand where air masses are and what they are, because that is what causes changes in our weather when air masses interact with another air mass at a front. So when you're finished with this assignment, you don't need to do the interactivity part here. You can submit it to Schoology and make sure that you understand these concepts so that you can do well on our quiz this week. We'll have a good day, everybody, and we'll talk to you later.